So what we're going to do this time is turfgrass diseases and their management. Originally, I was going to do like all the diseases that we have, that are really common that you'll see more often, but that is a big undertaking for 1 hour and it was just not going to work. Um, and yes, I did a presentation last month and Kathy has the recording. So if you want to watch it after this, then you can do that. Basically, the last presentation was just on a lot of vocabulary that you kind of need to know when you're talking about diseases. So if you're reading an EDIS publication, you might run into some vocabulary you don't fully understand. And then also just a little bit of a breakdown of the different pathogens that we have. Um, all right, so we are going to get into turf diseases, but first, going to review a little bit. All right, so for those of you that were on the presentation, does this look like a sign or a symptom? And again, let's just remember there's a little distinction between them. They're pretty similar. Sign is a little bit more specific. Symptom is more generalized. Um, Sign is more pathogen specific. Symptom is more a host or plant specific. Okay, so this is going to be a sign because again, we are seeing all these little orange globules are the actual spores of the fungus. In addition, this hyphae, this is actual like the body of the fungus, it's hyphae. So again, that would be a sign because sign is specific to the pathogen and it's a sign of the pathogen. Symptom is just generalized how the host responds. So in this case, fruit rot is a symptom, but the actual spores in the hyphae would be a sign. And here's a review of sign and symptom you can go back to. Again, I will give Kathy a PDF copy of this slide so she can distribute them out to all the master gardeners. And then, so after this presentation, you'll have access to it. All right, and then again, first with signs and symptoms. Symptoms are really similar, so they're generalized between the plants, so leaf spots, decline, something like that. Signs are very specific to the actual pathogen. All right, this is going to be a little harder if you were in the last presentation, so I'll kind of maybe breeze through this, but does anyone know if this is a biotroph or a necrotroph? I added this to be a little bit of a challenge, but again, let's try to remember bio is living, necro is dead, so in general, biotrophs are fungi that feed on living tissue, necrotrophs are fungi that feed on dead tissue. So in this case, when we see the fungus here with the hyphae or the mycelial mat, it is feeding on dead tissue because it's clearly causing the watermelon to decline. So this would be a necrotroph, and again, this is southern blight on watermelon. It's a necrotroph because, of course, it's killing the plant as it's progressing, so it feeds on the dead tissue. And then as a fun fact, it forms sclerotia, which are really small, hardened balls of hyphae that will survive in the soil for pretty much forever. All right, and so biotroph or necrotroph, this is kind of giving it away, but here the pathogen is here. It's that really brown, gray, fuzzy growth on the underside of the leaf. It is present here, but it's not present here. So that's kind of giving it away. So if I can see it here and not here, that means it's likely a biotroph, which basically means it is feeding off of the living cells. So it is extracting its nutrients from living cells, and that's how it feeds. It does not feed on the dead cells. So here's a review of them. You have the biotroph on the living side, necrotroph that they feed on dead tissue, and then semi or hemibiotrophs are in the middle, and most fungi are going to be in the middle. And the reason for this isn't so much to know the different names, like, you can kind of know them, but it's more important to understand that pathogens have different ways of living, different ways of feeding. Some of them are going to feed on living tissue. Some of them are going to feed on dead tissue, so they're going to kill off the tissue before they feed. And so this is just one way to kind of differentiate between the different pathogens and just how they choose to live their life. So this one again is a little bit harder if you didn't watch the last presentation. So we're looking at some symptoms and we're thinking about how we would describe these symptoms if we were to, send a picture to an expert and be like, hey, I'm seeing these symptoms, how would you describe them? So when I look at this, I see, leaf spots, obviously. They are leaf spots. They have these weird concentric rings if you look at them. And I don't know if I mentioned this last time, but the reason why some fungi do these rings is actually a day-night cycle. So it's similar to trees and how they have rings because of the different seasons. Some fungi produce different rings because of, again, the day-night cycle. And so again, that's really characteristic of fungal leaf infections is to have those rings. And again, fungi like to grow radially, so they grow a lot bigger just in a circle. And then once you get, and also the rings are usually called target spot symptoms because it looks like a target spot. And then sometimes when the necrotic lesions gets really dry and it'll fall out, the center will fall out, and that's called a shot hole. So again, this is called target spot. That's the actual disease name. It is caused by Rhizoctonia solani, also known as Thanatophorus cucumeris. And again, if you weren't on the last presentation, the reason why there's two different names is because that fungi have two different state life cycles. Really, they have the asexual and the sexual life cycle. And those two different life cycles look so vastly different. For the longest time, they were named different things. It's only since the advent of molecular data that we have discovered that they were actually the same pathogen. So that's why fungi have two names a lot of the time. And again, if you want to learn more, go watch the last presentation. So again, these have target spots. Also, the yellowing that surrounds the leaf spots is caused by a chlorotic halo. This is common of infections, so a lot of times they'll release toxins that start to degrade the tissue before the fungus actually gets there. And so that's a chlorotic halo. All right, so that was a review. If any of that sounded interesting, you can go watch the other presentation. If not, then that's basically what it was about. So today we're going to get into turfgrass diseases and their management. And so we have large patch right here on zoysia grass. Here is a really fun, it's one of my favorite pictures because it's like the extreme example of what fairy ring can look like. All right, so objective. So right now we're really going to focus on recognizing what are some of the different diseases we're going to encounter in Florida lawns. And I'm specifically focusing more on landscaping. So like homeowners, third type of lawns. I'll use a couple examples from like golf courses, mainly because that's where diseases are really, really prevalent, is in like really highly managed turf grass areas. So like golf courses or athletic fields. And then we want to differentiate between the different diseases, so know what they are and then how we can differentiate. Identify the environmental conditions that favor certain diseases, because again, when it comes to control, we really just want to use cultural practices that disfavor the disease. And then apply integrated disease management. And then last but not least, I'm going to talk about how we really want to communicate turfgrass diseases if we're doing like a tabling event or if someone comes into the Master Gardener clinic. All right, so we're going to start off with root rotting diseases. And so these are what you're going to encounter most often. They are really hard to they're hard to diagnose because again, they're in the soil, they're affecting the roots. They can look like a lot of different things. And so the most common one that we're going to encounter is take all root rot, and it's usually abbreviated as TARR or TAR. And I will say as an added note, I don't think I didn't put it on the presentation, but if you're dealing with Bermuda grass, it's technically called Bermuda decline, which is kind of confusing. I don't know why Bermuda gets its own name, but all other turf varieties is called take all root rot. And so the pathogen is Gamenomycetes graminis graminis. And again, under no circumstances am I expecting you guys to know that. We always just refer to it as GGG. And again, Gamenomyces is a genus, Graminis is a species, but of course, with fungi, you can't just stop there. You have to have different varieties within the species. And Graminis means grass, so it affects grass. So that's the pathogen. So some symptoms that you will see and how you can kind of diagnose it. So first of all, you will see it in spring and early summer. So it is more of a warm season disease. And this is important to remember because throughout this presentation, we're going to have different diseases that tend to skew warm season and some that tend to skew cold or wet or colder season. And that's important because again, that helps you differentiate, but all of them are pretty much all wet season. So if there's a lot of water, they're gonna, incentivize disease in some ways. But some of them are more prevalent warmer season, others are in the cooler season. So the way that we identify this, if you were to send it to a lab, would be to look at the lobed hypopodia on the stolons. And basically what hypopodia are, they are just little, little pieces that stick the hyphae onto the stolon. So these don't really go into, they don't go into the stolons much. They stay on the outside. And so those hypopodia are the only ways into the plants where they gather their nutrients and then kind of anchor into it. And so again, you don't really have to know the names, but one thing you can see is if you look at these really closely, you'll see again hyphae with these tiny little lobed like things that are kind of holding the hyphae onto the stolon. And one way my advisor would always talk about this is it looks like dirt that doesn't wipe off. So if you're looking at a stolon, and again, if you don't know what a stolon is, when we have grass, it grows, you have the leaf blade that grows up. And then above the ground, you have stolons that are just on the surface. And so they're kind of how it spreads. And then if it's below ground, it's technically called a rhizome. So that's just the horizontal growing region, basically. So if you look at the stolon, and St. Augustine has like really large stolons, and that's why we see it most often on St. Augustine. So yes, if you look at the stolons and you see some dark stuff on the stolon, you can kind of gently try to wash it off with your finger. And if you brush it off and now all of a sudden the stolon is clean, it probably was just dirt. If you're brushing it off gently and it's still kind of remaining, it's probably more likely to be the GGG or the take all root rots. So that's one way you can kind of tell. And again, this is very common. So if we ever do like an in-person like training, I will definitely be able to find some of this and we can look at it. And it's really fun to look at it under the microscope. All right, so again, it's really common. It's in the same, and this goes with all the soil inhabiting fungi that I'm going to talk about. They are in soil no matter what. So they're always going to really be present in some level. It becomes more of an issue when you have stress turf. And again, you'll hear me say that a couple times. It also is more of an issue with high pH. And as some of you might be aware, when it comes to the soils that we have in urban environments, it tends to be a little bit higher pH. A lot of times that's because just the building process, we strip off the top layer and then we add fill dirt in to, lift up the houses. So there's a lot of factors in urban communities that make the pH a little bit higher. Wet conditions, this is true for most all of the ones we're going to talk about. Shade, again, shade is an inherent stressor because it prevents them from getting optimal light. Compacted soils is the big one. If you have really compacted soils with poor air circulation, it's going to really favor the development of this disease. And again, when you notice the actual fungus itself, which let's just review, this would be a sign of the fungus. And then on the next slide, this is a symptom, because this is how the plant responds. This is the actual presence of the fungus. So when we are looking at it, it is present on the stolons, but it primarily works as the root rot. So it will cause the roots to be rotted, to be black, to be stunted, to have very few of those fine hair-like roots. All right, so this is what happens above ground. So this is what you're going to see. And again, when you look at something like this, there are ways that can kind of make you think that this is probably take all root rot, but also it's really impossible to be 100% certain without investigating further. So maybe this could be, an herbicide application that went wrong, or an environmental condition, or chinch bugs, or something like that. So this looks like take all root rot, but if we got a picture in here, if like a client came in and showed us a picture, we want to investigate it further before we were for sure um, saying that it was take all root rots. All right. So when it comes to management of this, we're going to first focus most importantly on cultural conditions, because like I mentioned, take all root rot or the pathogen is going to be present in the soils no matter what. The reason why it actually causes decline in some turf is because it's inherently stressed and already weakened for some reason. So let's test the soil. Again, if you have high pH soil, you'll know that you're a little bit more susceptible to this disease. And it's really hard to lower the pH effectively. So really, if we want to do that, just try acidifying fertilizers, and that will help prevent the pH from really getting higher. But it's really hard to properly lower the pH. An important thing to note, when you have symptoms like this, once the symptoms, this is a root rotting pathogen, so it is affecting the roots. Once you start seeing the signs on the leaves, that means the roots are like completely shot. Like the roots in this system are really, really bad at this point in time. So if you were to apply like a regular dosage of fertilizer, it's all going to leach out. The roots are not capable of actually taking in all of this because they're so damaged. So we want to spoon feed the turf. We want to give frequent but really, really small dosages of fertilizer because, again, the roots are too damaged to take in a normal amount of fertilizer. In addition to that, micronutrients and also even applications of nitrogen and potassium are another way to kind of help with help kind of get the turf back on track. So again, it's really damaged. We want to slowly get it back to health. Aeration, again, is really important. A lot of urban soils are really compacted, so it's really hard for the roots to get deep. So it's hard for them to, really find their way down the soil layer. And then also aeration kind of helps and decrease the moisture and, disfavors the pathogen. And then another important thing to mention, and I'll probably mention this a couple times, once we get to this point and we start seeing these symptoms, the fungus has been in the soil and it has been active for many weeks now at this point in time. So this is late stage. So it's really hard for us to do much once we get to this point. We want to catch it before it gets to this point. Of course, we can get worse. Once we start seeing dead patches, then so we want to get here sooner. And then I saw a question that says, do we need a microscope that is capable of seeing the signs? Yes and no. So if we want to see this, you need a microscope. But like I said, if you want to just see that the stolon is kind of dark, so again, stolon is supposed to be green. If it looks like it has some gray tint to it, and you just rub it with your finger and it rubs off, soil. If you rub it with your finger and it doesn't, that's likely this. So if you want to confirm it, you need a microscope. If you're like in the field or you're just taking a quick look, that's just rub off test is a good like kind of first thing that you want to do. So most likely you'll need a microscope to be more comfortable with seeing this. But technically, once you get a little experienced, you don't actually need the microscope, but I would still want to confirm with a microscope. And this is just a regular dissecting microscope. It's not a compound one. So you can see this with a regular one. All right. Large patch. So I feel like this one is probably talked about, again, second most after take all root rot. So this is caused by Rhizoctonia solani. And again, it's a soil-borne fungus. It's going to be living in the soil no matter where you are or what you're doing. So it appears as circular patches of tan to reddish brown grass. So the difference is with take all root rot, it does appear in patches, so it'll start in one area and then spread, but it tends to be irregular shaped patches. So you see this is kind of irregular, and that's because it follows the stolons. So it'll do like a whole line of, starts to decline the turf in just that line kind of. So it's kind of irregular patches. With Rhizoctonia or large patch, it is more circular patches, but they aren't exactly always perfect circles. And so again, more circular, they can range in size. So sometimes they start off really small, and then they get larger. Sometimes they coalesce, so they'll start to merge with each other, and then it kind of gets, more irregular in shape. And then this is a cool season disease, so you will see it more when temperatures are below 80 degrees. Still wet, it still prefers wet conditions, but colder wet conditions. Um, and so this pathogen does not technically infect the roots. What it does is it infects the very base of the leaves. And so what it does is, it kills off the base of the leaves, which kills off the leaves themselves, which will inherently affect the roots as well, because there's no photosynthesis that's keeping them, alive and healthy. So it does affect the roots if it's been present for a while. But technically it affects the base of the shoots. And that's one way you can kind of try and diagnose it is if you can just pull off, if you just grab some of the grass and you can pull off the leaf easily, like there's no resistance to you pulling the leaves off. Kind of like if you were to pull your hair, like if I'm pulling my hair now, there's resistance because it's inside my follicle. If that follicle is like rotted, I could pull my hair out easily. So that's one way to kind of differentiate between this and the other ones. And so here's an example. So again, this is the leaf blade. This is where it's normally attached to the stolon, but it's rotted here, so you can just easily pull it out. But again, this happens when it gets a little bit more of that advanced stage. So, we do also want to catch it a little bit sooner. All right, so here we're going to go through some conditions that favor the disease, and then management and prevention, which are kind of two sides of the same coin. So whatever you favor, you want to just inhibit or do less of for managing it. So when it comes to overwatering or drainage, again, most of these diseases prefer conditions that are wet. So if you overwater, you're going to get more disease. So obviously, if we want to manage that, we want to improve the drainage and irrigate effectively. This is one of the diseases that is really good at eating up nitrogen fertilizer. So when it comes to applying fertilizer when you have diseased turf, it's important not to apply too much because again, the roots are affected, so they can't take in the fertilizer properly. But another thing to consider is the roots actually, or the pathogen itself, is able to take in that fertilizer. Because fungi in their nature, they take in their nutrients from their surroundings. They're not like plants. They don't create their own photosynthesis. So they take their, nutrients from their surroundings, which can include fertilizer a lot of the times. And so that's what this pathogen is really good at. It's good at eating up the fertilizer that we intend to use for our plants, but instead we're just strengthening the pathogen. So this is another reason why we do not want to over-fertilize, especially if we have disease symptoms. And this can be counterintuitive. A lot of people see symptoms and they decide they just want to throw fertilizer and see what happens. But sometimes that makes it worse. All right, thatch buildup. That's another thing that's more specific for this pathogen, even though it can kind of be the case for the other ones. This one really builds up in the thatch, which is just the dead leaf, dead stolon, dead material that is left on the surface of the grass. So it'll build up populations within the thatch, and then it'll kind of jump to actually infecting the turf. So large thatch is another thing that causes the disease to be more prevalent. And yep, extended period of leaf wetness, cool weather, shaded areas. Again, shaded areas tend to have less airflow. They are shaded, so they have less evaporation, so the leaves will stay wet for longer. Those type of conditions will increase disease incidence. And then as far as management, most of this I mentioned, limit nitrogen, improve drainage, dethatch, which you can use just like a metal rake with. There's certain chemical products that can help remove the thatch. And then there's other ways to remove thatch. And then fungicides. Again, we want to apply fungicides at the first sign of disease. So once these get really extensive and they start causing a lot of dieback, it's going to be really hard for us to manage. And I have another slide at the end of these, which I'll talk more about that. But again, fungicides are preventative. They are not curative. So they do not kill the fungus that is in the soil. They weaken it, but most importantly, they prevent it from infecting the plants. So once the disease is getting really, once it starts to increase, especially more rapidly, the fungicides are going to have less, they're going to be less effective, basically. All right, so this thrives cool, wet conditions. Pythium root rot. So again, another root rotting pathogen. This is caused by Pythium, which is a water-loving fungal-like organism. So again, if you were in my last presentation, there are these fungi-like organisms called oomycetes. And basically they are very similar to fungi in the sense of how they behave, how they act, but evolutionarily, they're very vastly different. They're more closely related to algae, and fungi are more closely related to like insects and us, pretty much. So they behave similarly, but they are different enough that sometimes that is a consideration with fungicide applications. So there are some fungicides that are effective on both, oomycetes and traditional fungi, but there's some that don't have overlap. All right, so key symptoms with Pythium. Again, all warm season turf grasses, and I guess before I continue, just know that we're in Florida. All of our turf grass is pretty much warm season. When you go up north, you have different types of grasses, and so there'll be different diseases in that case. But these are all things that are common only on warm season turf grasses. All right, so Pythium is really common in golf courses, athletic fields, stuff like that. It's really, really uncommon in landscaping and lawns in general. And this is just because of how they're managed. So you have to be seriously overwatering in order for you to get a really bad Pythium infection. Not to mention Pythium it's more of an opportunistic pathogen. Like all these pathogens are opportunistic, which means they will wait until the turf is really stressed before they infect. Pythium is like that, but the turf has to be really stressed for it to actually cause noticeable symptoms. But again, Pythium is constantly present in the soil. It will be in the soil no matter what. It's whether it causes disease or not is only under seriously overwatered conditions or seriously stressed out turf. All right, so the symptoms it causes are general turf thinning and discoloration. So unlike the other two that we just talked about, the take-all root rot and the large patch, they have very patchy distribution. This one is going to be less patchy. So sometimes it'll be kind of patch-like, but it'll be more uniform across the landscape as long as it's all overwatered. So the roots will appear sparse, discolored fruit, and a few root hairs. So I have this picture, and this is from, when I was in the clinic, and all this little grayish white hyphae is the Pythium. So again, that's a sign of the Pythium. It doesn't always do that. So Pythium cultures out really easily, but it's hard to see unless you send it to lab to be cultured out. So when it comes to a large patch and take all root rot, there are ways that I can kind of identify them here in the extension clinic. If you have enough training, you can kind of do that way. With Pythium, it's going to be hard to do that unless you have used like traditional methods used in a lab. But in this case, it did grow out on here, and you can look at this. This is the shoot, and it's Bermuda grass. This is the shoot. There's like almost no roots along the stolon. So it really blights off all of these roots. But this is a severe case, and it's also from a golf course, which they irrigate a lot. They have a lot of amendments, a lot of foot traffic, so it's not as common on landscapes. And then here's another example. Again, this is a golf course because it's much more common on golf courses. You can see it kind of patchy, but in general, it's, there's little bits and pieces all over. And if you're wondering what these holes are, that's from aeration. So in golf courses, they aerate soil a lot. And again, that's a management technique, and it's one that's utilized a lot in heavily managed turf. It's not utilized a lot in like landscaping turf, even though it is effective as well. All right, so when you manage Pythium, first of all, just prevent overwatering. And again, that's half the battle. Because this is, it's a water loving, so it really likes the water and it will spread fast if there is the right conditions. Improve drainage, reduce soil compaction. Part of that is being done here by aeration. Mow at the proper height, reduce foot traffic when wet. So again, if we walk on grass when it's wet, that increases compaction. Also, if we mow too low, that's increasing the stress of the turf. So we want to reduce those. And again, just general best practices. And if balancing nitrogen with potassium, so kind of like the other ones, we want to have a balanced fertilizer regime. And then fungicides, here are some of the ones, but again, we need to apply them preventatively. So once you have dead grass, this grass is never going to heal. All we can hope is that this grass kind of comes in and fills in the gaps. And we hope it does that before weeds come in and fill in the gaps. Can you guys see my mouse? I just realized you might not be able to. Can you see it now? Yes, no, maybe. Well, I think now you guys can see it. Okay. Well, regardless, Pythium, it tends to be a little bit more spread out. It's not in distinct patches. Okay, so here is a table, and this is something that I'll also send to Kathy in like a PDF copy version. And so basically, this is just a good way to kind of help you differentiate between the main root rotting pathogens. So these are going to be the ones that are found in the ground. They're going to be hard to identify because they just cause that general decline of the turf. And so basically, we have take all root rot, large path, Pythium. So what causes it? What's the season that it's active? So these ones are warm season. This is cool season. This one is pretty much all seasons that there's a lot of wetness. What turf is affected? So all of these are warm season turf grasses, which we have here in Florida. St. Augustine is particularly susceptible to take all root rot. St. Augustine and zoysia are particularly susceptible to large patch, and then all of them are pretty equally susceptible to Pythium. And then symptoms, so these are our regular patches. These are more circular patches. Pythium is no patches. Speed of spread, so Pythium will spread very fast given the right conditions. Take all root rot, it'll spread moderately fast. Large patch is pretty slow, so it'll just grow a little bit each season pretty much. It's going to stay in the soil during the off season, so the warmer time of years, it's going to be kind of mass because the grass is growing really rapidly. And then as soon as the temperature cools down, you start seeing the symptoms again. They're all triggered by stress, no matter what. If you have stress, it's going to cause more disease. Take all root rot, you have higher pH and compaction is more prevalent, favoring that disease. With large patch, thatch, and high nitrogen is going to favor that disease. And then Pythium, high wet and water conditions are going to favor that disease. Cultural focus. So again, when it comes to managing, these are how we would manage them. So again, manage the stress is the most important factor. And then for fungicides, all of these we need to apply preventatively. Nothing is going to absolutely kill the fungus. Take all root rot is harder to control with a fungicide, so we really want to focus on cultural control. These other ones we can control with fungicides. But what we need to make sure we understand is that we cannot kill them with fungicides. We just control them. All right, so does salt affect fungi? Yes, it does, differently than plants. So sometimes If you have salt stress plants, that's just another stress that's allowing fungi to come in because fungi are sometimes less affected by salt. But I don't know specifically. Um, but yeah, when it comes to salt, it does affect them, but more so it affects the plants, which the fungi can utilize that. All right, so let's summarize the different root rotting diseases. And again, these ones are pretty common for us to encounter. So first thing first, I would just want to make sure that we know that these are just a general rule of thumb. So, living organisms don't like to be put in boxes, and each unique condition is different. So every house is going to have a unique microclimate with, unique inhabitant of soil, microbes and fungi. So every situation is very, very unique. So they don't always follow a textbook, which is why it gets really challenging. So if we're ever unsure, we like to take lots of pictures, send those pictures to the lab, and I'll link the lab at the end of the presentation, and then send samples to the lab. And that's just the best bet if you want to be most certain. It's also common to see co-infections, multiple infections. So this is an example, and again, it probably doesn't mean much to anyone but me on this presentation, which is fine, but it's just a way to show, and this is a stolon on St. Augustine. So this larger hyphae is all, again, I don't know if you can see uh, my mouse, but the larger hyphae on here is going to be all, it's going to be Rhizoctonia. And then all of those little dots that we see underneath is the take all root rot, or the GGG. And so a lot of times what we'll see is kind of almost a changing of the guard. So as the seasons change, the disease will kind of go from favoring one to the other. So this, I can almost guarantee, was probably taken sometime in the fall when temperatures are starting to cool down. So again, it's kind of changing from having the take all root rot affecting the grass to having more of the large patch start to affect the grass. So again, co-infections are not uncommon. And again, these pathogens are present in the soil no matter what. All right, so some more key takeaways. So when we talk about fungicides, we want to apply them early. It's really common for some people to, when they think about pesticides, their first thought is insecticides, which work by actually killing the insects. So when we apply an insecticide, we spray it, the insects that are present are going to die, and that's how they work. With fungicides, it's different. So fungicides they aren't curative, so they do not kill the fungi, especially not the fungi that are in soil. They are mainly preventative. So they are preventing the plant that we are spraying from getting sick, from getting infected. They can sometimes weaken the fungi, but they're not going to kill it. And so that can be a misconception, is that when we apply a fungicide to the soil, we are killing the fungus that is in the soil. When in reality, we are preventing it from infecting the plant, not so much killing it. And so that's why if you only rely on fungicides to control your problem, you will be fighting a losing battle. Some people will apply fungicides really, they'll have a good schedule for one season. They won't notice any symptoms on one season, and then they think they're done. And then next season, the symptoms pop up again. And that's because they didn't kill the fungus. They weakened it, they strengthened the turf by having it not be infected, but they're not killing the fungus. And again, if you have a history of these diseases, so you know that this is present, you've had issues in the past, get on a preventative schedule before you start seeing the symptoms. So we want to be proactive, not reactive. All right, so one analogy that I kind of use for fungicides, and this has helped me in my brain to kind of understand, and so we want to understand that fungi live in the soil, and this is true of all fungi, even foliar infecting fungi, but it's mostly true with soil infecting fungi because there is no way that we are going to get into every nook and cranny in the soil in order to kill it. So even if we had fungicides that were curative, so they actually killed the fungus, there would be no way for us to kill all the fungus. So this is kind of like with Fumigants. So fumigants are applied to soils and they wipe out everything. So before you have tomatoes or strawberries, they fumigate the fields, apply plastic, and then they plant. But they fumigate the fields every single season because even with fumigation, um, it's not going to kill everything and the populations will build up again. But with fungicides, again, they don't kill, they weaken and they prevent them from infecting. You are not getting rid of them. So I like to think about fungicides as an umbrella. So the fungicide is the umbrella, the rain is the disease. So if you apply a fungicide, you're basically providing an umbrella to protect the turf or the plant or whatever you're protecting from the disease. But you're not stopping the rain. So fungicides won't stop the rain. They're just going to stop, what's under the umbrella from getting wet. Another way to think about this is also if you're already soaked, so you already have really severe disease symptoms, and you open the umbrella over yourself, it's not going to do much. You're decreasing how much effectiveness the fungicide is going to have, or the umbrella. So like if I'm soaked and then I decide to open my umbrella, the umbrella's not going to do much. It's really like at this point in time, is it worth using the umbrella? Like I won't get more wet, but I'm already pretty wet. That's the same thing with fungicides. If we apply them after we have pretty severe disease symptoms, yeah, you're going to prevent the disease from spreading more, but you're already having really bad symptoms. They're going to be less effective as if you were to apply them earlier on. So this first sign of rain is when we, put the umbrella up. So the first sign of disease is when we start adding those fungicides. If that's how we want to manage our lawn, of course. A lot of these diseases, the turf will kind of grow through, given there's less stressor conditions. So if we don't want to have a perfect lawn, then maybe we don't need this. So it's just things to consider. All right, so that's the end of my true soil infecting fungi. Are there any questions on that? All right, I will continue to move on. And again, I'm monitoring the chat, so if you have questions. Okay, so next, fairy ring. So this is also soil inhabiting, but I don't really have this with the other group because it's actually not a true pathogen. So this does not infect the grass. It does not obtain any nutrients from the turf. Basically, it's a group of fungi, and it's a whole long list of different fungi. So it's not like a very specific group that caused this disease. Um, and they feed on decomposed organic matter. So if there's a buried log, if there's roots that are decomposing, the thatch layer is really important. They are going to feed on that, but they're not going to infect the turf. So they don't infect living tissue. Therefore, they're not technically a pathogen. However, they can have some indirect damage, and we'll talk about that in the next slide. All right, so symptoms of this. Again, found in all warm seas and turf grasses. It is also really common. Again, like all of these, it's going to be present in the soil no matter where you're at. So, preventing it from, getting into the soil is kind of a losing battle. It's going to be there. It's mostly noticed during the warm, rainy season because that's when you start seeing the mushrooms. But it's obviously present in the soil all year round. It's noticed mainly by rings. They can be full rings, they can be incomplete rings, and they will expand over time. So like each year they get a little bit bigger, kind of. All right, so there are 3 different kinds of fairy ring fungi, and this is kind of where we differentiate whether it's a problem or not. So type 1, which is the ones that are the most of the issue, and it's caused by soil and thatch that become hydrophobic. So the soil and thatch become hydrophobic due to some of the compounds that the fungi releases. So, and this is what leads to the turf decline. So it's not the fungi infecting the turf. The fungi release compounds that cause the turf to be hydrophobic, aka they repel water, which means the turf declines due to drought, basically. So that's why it causes decline, not so much. Um, does a mulching mower contribute to thatch? Actually, there's a lot of research about this, and no, it doesn't. So if you leave the leaves on the ground, some people think that increases thatch. In reality, that doesn't really increase thatch. What increases thatch is excess nitrogen, and then also decreased aeration. So once you have the leaves that are on the ground, they will be broken up relatively quickly by you know, microbes in the soil. When you have thatch, again, it's that too much nitrogen, not enough air to kind of allow things to break down. So they'll break down pretty well if there's air, but once you get it all compacted and without airflow, it stops the breaking down process. So no, mulching mower is okay. And in fact, it's, usually it's mostly known to be beneficial to leave the leaves. Um, so, but that's a good question. Thank you. All right, so type 1 fairy ring, they cause actual observable symptoms, but they don't infect the turf, it's just a side effect. Type 2 are kind of weird and they appear as dark green rings or arcs of faster growing turf. So they actually kind of enhance the turf in the area where the fungus is most present. And so sometimes, and it's thought that this might be due to the fact that they're breaking down organic materials, so making it more available. It's not entirely sure. Again, it's not really damaging the turf at all, but it can be unsightly. Some people just don't like the ring look or the darker rings. Um, Having said that, it's really hard to manage these rings, and it'll probably take a couple years maybe for them to fully go away. And again, you can apply a fungicide, but you're not killing the fungus, you're just weakening it. Um, and so type 3 is the ones that produce mushrooms or puffballs in a ring or an arc. And these are the ones where you'll see the mushrooms in a ring, but again, it has no real effect to the turf grass. All right, so when it comes to fairy ring, obviously type 1 is going to be the one that we're concerned about. This in this image is type 1. So clearly it's causing a decline in the turf where the mushrooms are present. And that's because it's creating some compounds that cause the soil to be hydrophobic. Um, and a lot of times, and again, it spreads over, the seasons, over the years, it'll continue to spread. And so that in between area, the stuff in the middle, will get usually recolonized by weeds or a different type of grass species. So even though it'll eventually green up in the middle, a lot of times it's a different type of green than sometimes we intend. People like their very specific type of turf. And then prevention. So when it comes to fairy ring, again, I want to emphasize that fungicides will suppress the fungi, so they'll weaken it, it'll grow slower, probably won't reproduce as much, but it's not going to get rid of it in the soil. It's still going to be present in the soil. You're also not going to change the hydrophobic soil conditions. That's just not what fungicides do. So if you're experiencing the hydrophobic conditions, and the way that we would check for that is just feel the soil. Feel the soil in that dark area, the area that's declining. If it feels dry, and then you go right next to it, the area that's healthy is that wet. So you kind of compare the two. And if it's significantly drier in the area that's declining, then that's probably a fairy ring fungus because, you're not supposed to see a very stark difference between the water level in the soil, judging by like the difference in a foot. So that's how you tell. And in order to prevent this or to correct it as best you can, we want to aerate the soil. And so the way that we can do this in a more precise manner is you just take one of those metal pitchforks, shove it in the ground. You can kind of move it back and forth just a little bit. And you do that for the entire ring. So you just kind of go down the ring, you aerate the soil, you apply a wetting agent. So this is some kind of compound that allows the soil to get wet again. And then you'll need to do more frequent irrigation events over just the ring. So again, the center of here, the majority of the fungus has left. it grows radially. It's mostly active in the tips. So in the center, it's pretty much gone. Um, so we don't need to irrigate the center area as much because that could lead to more other diseases. But the area that is hydrophobic, we want to irrigate that more often just to get it wetter again and kind of remove those compounds that cause the hydrophobicity. All right, so here's just a PSA. So I'm sure a lot of us, if you're in the clinic or just deal with homeowners in general, they will come in with just a white mushroom that's on their grass and they'll be like, is this killing my grass? Is this affecting my grass in any way? And they'll pick up that mushroom from just green turf. And in that case, I would say in 99.9999% of the cases, if you have just a white mushroom in your lawn, it's not causing any harm to the turf. It is just decomposing already dead organic matter. So the vast majority of the time, it is harmless. To the turf, not saying it's harmless to you. Some of them are toxic to people or pets. So, but if that's the case, just remove them, that's just handpick them if you have kids or something. So some of them are toxic to humans, but they're not toxic to the grass unless you're seeing actual symptoms like this. So unless you notice actual like above ground symptoms, you feel the soil's oddly dry in this area and then super wet in this area. Unless you're seeing this, it's not an issue. And again, you can have fairy ring without having noticeable mushrooms. Sometimes it looks just like this. So the first picture in type 1, there's no mushrooms there. And we were able to determine it was fairy ring because of the hydrophobicity. Again, you can also send this to a lab and they can culture it out, or at least give you a better determination. All right, so those are all the root rotting pathogens, and then fairy ring, which is kind of root rotting adjacent. I don't want to include it in the same group because again, it's not a pathogen. But a lot of people will read about it and they'll be like, oh, I have fairy ring in my lawn and how do I control this? And to that, I would recommend that you say, there's no way to get rid of the fungus. If it's not causing a problem, just, if you don't like the mushrooms, pick out the mushrooms and remove them. If it's causing symptoms, there are some things you can do, but fungicides aren't going to prevent the symptoms really much at all. So now we're going to move into foliar diseases. And then again, if you have any questions, you can put them in the chat. So with foliar diseases, these ones tend to be only a problem in usually sod production. So there'll be a problem when you're producing sod. And also under heavily irrigated systems, again, this rings a bell, pretty much all of them are under heavily watered conditions. And then very specific environmental conditions. So a lot of times in shaded areas, so under a big tree, you might notice there's more leaf spots than elsewhere. This is a combination of factors because the shade kind of prevents evaporation, it stays moister for longer. That's also improving the disease. So yes, I'm only going to talk about 2 different leaf spotting pathogens, gray leaf spot and rust. There are more, but most of them have very similar management practices. So it's not really worthwhile to go through all of the ones that can possibly be in the landscape. These are by far the most common. And if they're not them, they're probably managed very similarly. And if they even need to be managed at all, again, they're usually not a significant problem unless there's very specific conditions. And the first thing, if someone were to like come into the clinic with, significant leaf spotting issues on their turf, the first thing I would think is, you are over irrigating. What are your irrigation practices? How can we change them? And these are 2 examples of gray leaf spot, which we'll talk about next. All right, so gray leaf spot, sometimes abbreviated as GLS. It's caused by Pyricularia griseae or Magnaporthe griseae. Again, remember fungi, they have 2 names because we like to make things complicated. But in reality, it's because fungi are just really complicated and they have an asexual and a sexual stage. But we mostly call it Pyricularia. And so some key symptoms are you're going to have, and this is very, very common on St. Augustine grass, can be prevalent on the other ones, but it's most likely on St. Augustine. And it's warm, rainy weather. So again, it's more warm season, definitely really rainy or just heavily irrigated systems. So it's going to cause oblong leaf spots. So circular-ish, but they're kind of like, oval leaf spots that kind of are usually in, the same line as the leaf veins. So when they're really wet and humid, it looks kind of olive green and the center is going to be really gray. And this is because they are prolific spore producers, which is one of the reasons why once you start getting it, it can spread really fast because there's thousands of spores in each of those leaf spots. So they produce a lot of spores. Um, and so eventually they kind of cause the lesions to coalesce and they can cause the whole leaf to blight. So that's when it gets bad. If you start seeing leaves actually start blighting out, and by blight, I just mean it's getting, you can't see individual leaf spots. It's just the whole leaf is dying. That's when you start having issues. And the good news with foliar pathogens is fungicides are a little bit more effective at minimizing, you can minimize the inoculums of the spores. Soil fungi tend to spread just normally through hyphae. They slowly spread in the soil. They don't tend to be really prolific spore producers if they produce spores at all. With foliar infecting stuff, they're produced a lot by spores, which are moved in the air and in the water. So if you apply fungicides, you can prevent them from sporulating, which decreases the inoculum, which minimizes how they spread. So that's the good news, is that fungicides are a lot more effective when it comes to if you have like a severe outbreak, it'll be more effective at bringing it down. And then it's, again, like everything else, more common on stress turf. Although this is one of those ones where if you have really healthy turf that's just really wet and there's just disease is present, there's spores in the air and in the water, you can still get disease, even if the turf is otherwise relatively healthy. And again, this is something that is pretty easy to confirm once you know what you have, or you know what to look for. So like if anyone ever has a concern, I can easily tell what's gray leaf spot or not, so you could just bring it to me. And then here's management, and then this is another example of gray leaf spot. This is when it's not quite as wet, so there won't be as many spores on here, but you can still see it's kind of oblong shape. It's like a muted tan center and a dark brown outside region, the border. And then you can also see where the leaf is starting to blight. So that's when it starts, the infection kind of ramps up, gets more exponential, so it starts spreading faster. So management, water in the morning. Again, we've heard this a million times. Water in the morning is the best time to prevent the leaves from staying wet for too long. Avoid excess nitrogen. This is the case for all of them. Again, so nitrogen, the fungi can sometimes feed off of the nitrogen. Also, nitrogen causes grass or other plants to grow rapidly, but grow tissue that is not defended well. So it grows like really lush tissue that has not enough defenses, and it's also just really yummy for insects and pathogens. So that doesn't mean we don't apply nitrogen. We just want to make sure we apply the correct amount of nitrogen. Mow at recommended heights and with sharp blades. We want to decrease wounding. So if we have really dull blades that aren't cutting the grass, they're just kind of ripping the grass in two, that's what we want to prevent. And then mowing height is important. So we don't want to mow it too low because again, that's a stressor that prevents photosynthesis because there's less green tissue. So that means less root growth. That means the grass is weakened. So we want to mow it as high as we can, and it's still like optimal for us. We don't want to leave it too high that we can't walk through it, or then you also start to decrease airflow. So look at the recommended height. With St. Augustine grass, it's usually 3.5 to 4 inches. Also check your mower. Sometimes mowers don't have like specific inches on them. So you're just kind of guesstimating what is the right height. And so maybe just check your mower because you might be guesstimating wrong. So that's just a good thing to do every now and again. And then fungicides, they work, they are still preventative. So they're not going to cure the diseased tissue, but they are going to prevent it from sporulating, and that's how it really ramps up disease is for spores in this case. And then here's an example of some of the spores. So again, you take a tape mount, and whenever we do like an in-person training, I'd love to teach you guys how to do tape mounts. It's really fun. Um, and you can see there's just a bunch of spores in just a really small area. Um, and this is something we can do in the lab. So it takes a little bit of training to see the spores, but um, it's possible. All right, so next we have rust. So rust is again a disease that is on a lot of different plants, but it's also on turf. Um, and so it's caused by different rust species. It affects St. Augustine and zoysia grass mostly, so like we don't really have much rust on Bermuda grass. Um, this is another cool weather fungus. So it will be most prevalent when the turf is dormant. And this is because it kind of needs time to, to actually go through the plants to make spores. So like the internal infection takes a while, and then it bursts through the skin of the leaf tissue and creates all those really bright orange spores. So this is going to happen when the grass is dormant and it's not growing so fast. Um, and again, it's going to create these linear lesions that kind of follow the veins of the grass. Um, and if it's a really severe infection, it can cause really chlorotic looking grass that gets just thin and patchy. And this is almost never lethal to turf, and it's very rarely a problem. Only in very specific conditions are we going to find it being a significant issue. And then another thing that I'm going to mention is that it sometimes is mistaken for sugarcane mosaic virus, which I have one slide on, and I'm just going to briefly go through that. Sugarcane mosaic virus is not technically present in Manatee County yet. I think we had like uh, one, case of it, but it's really not common in Manatee County, but it is more prevalent further south, so you might get questions about it. All right, so managing rust. Again, balanced fertilizer. So that's equal nitrogen to potassium primarily. Water early in the morning, avoid irrigation. It's all pretty much the same things. You can apply fungicides. Again, it doesn't usually get to the point where you need fungicides. And then here's an example of rust on a leaf. You can see um, the little orange linear lesions that has a bunch of spores in them. This leaf also has clearly nutrient issues, so it has a nutrient deficiency going on. In fact, this specific grass had a lot of take-all root rot, which was affecting the roots, which affects nutrient uptake. So you can see the linear chlorotic stripes. And then next I'm going to go through sugarcane mosaic virus and also lethal viral necrosis. So we'll kind of go through what's the difference between the two. I want you to be aware that we don't really have this yet, so you don't have to be you don't really have to know what it looks like too much, but just be aware that it is a big problem down south. And not that far south of us, to be fair. It's definitely been found in Sarasota County. It's not super widespread in Sarasota County, um, but it's something to watch out for. So this is caused by a virus, so that's much different. There's very few viruses that affect turf. This is one of the few ones. So the difference between sugarcane mosaic virus, or SCMV, and lethal viral necrosis is that Floritam St. Augustine. So Floritam is a cultivar St. Augustine. That's the only type of turf that is going to progress to the lethal viral necrosis. So basically, any turf can get sugarcane mosaic virus. They can get the virus. They will have certain symptoms like showed here. So the kind of mosaic chlorotic streaking that you see there, that intermingling of the light green to the dark green, they will have those symptoms. But Floritam will progress to a lethal viral necrosis. So basically, after a few seasons of being infected, it'll start getting necrotic, and then it'll start dying. And so again, it can have that yellow rust-like vertical kind of lesion. So if you look at this picture and this picture, you can kind of see, it's not the best comparison, how they can get confused every now and again. And again, there can be co-infections. So you can have the virus and also have rust. Um, so that's the only time when rust can be a little bit important is if you're in South or like Miami-Dade County and you are worried about having sugarcane mosaic virus and you see rust, you might want to send it in to be tested just in case. And same thing with sugarcane mosaic virus, it's more common in the colder months. And this is because when the turf grows slower, it's more likely for the symptoms to be observed. So the virus is still present when in the warmer months when the turf is growing more rapidly, but you don't see the symptoms. And because this is a virus, there is no treatment. If you have Floritam and you have sugarcane mosaic virus, you can assume that within time it will eventually progress to lethal viral necrosis and it will eventually die. So you want to replace your sod with a resistant cultivar. All right, so that's just a little bit of information about that, which again, we don't really have much of, we don't have here, but it might be important to be aware that it is something that can potentially come here. All right, so now I'm going to do a little bit on nematodes before we wrap everything up. Nematodes technically aren't pathogens. Some people consider them pathogens, some people don't. Um, so again, nematodes are microscopic roundworms. So they're kind of like a dog heartworm is an example of a nematode. They are ubiquitous in the soil, but only a few of them feed on plant material, typically the roots. But we do have some plant parasitic nematodes, and I will say they are one of the biggest challenges when it comes to all turf production. So like golf courses struggle with nematodes a lot. I honestly suspect that homeowner, like just regular lawns, probably have higher nematode pressures than we realize. But the problem with nematodes is it's really, really hard to control them. There are really no nematicides that we can apply to homeowner lawns. And the few products we do have aren't going to be like crazy effective. So when it comes to managing them, we only really have cultural control methods. And this picture is just an example of how severely they can infect the roots. And really, they really minimize the amount of root tissue that the grass has, which also correlates to less, nutrient uptake and stuff like that. So with nematodes, they cause irregular turf decline. So they will resemble drought, disease, or nutrient deficiency. So this can be pretty similar to diseases in the sense that sometimes it's really patchy. And again, nematodes, they spread in the soil. The only way to really move is if you move the soil around. So like if you're digging with a shovel and then you take a shovel that has soil particles on it to a different location, that's how they move. But other than that, they just move really, really slowly in the soil. So they're going to be really patchy. So one area might have crazy numbers of nematodes, and then just like 10 feet away, relatively minimal nematode numbers. So again, they're pretty patchy, which is characteristic of a lot of diseases too. Not only that, but nematodes cause wounding in the roots, which can be entry sites for lots of diseases too. So again, co-infections are really common. They will come hand in hand with diseases as well. A lot of times weeds will start to invade. So weeds like spurge are more resistant to nematodes. So you might start seeing more of those type of weeds. They're really, really problematic in golf courses because golf courses are heavily managed. They're very uniform. So again, variety breeds resistance. And they're heavily irrigated. So this is really problematic, but it's also can be an issue in lawns. But again, there's not much we can do about it. Um, all right, so the only way to actually confirm if you have nematodes is to send it to a nematode assay lab. So I can kind of check if there's root knot nematodes, which is a specific type of nematode, which I have pictured here. Over here, you have the female nematode, which is this like round circle. The root knot nematodes, typically they look worm-like. But then for root knot nematodes specifically, once they get into the roots and they start feeding, they swell up like a water balloon. And then here you also have eggs. So she's producing eggs. Those eggs will hatch. They'll swim around in the soil and they'll find healthy roots, infect the healthy roots, and then cause them to decline. Um, so again, if you want to determine if you have nematodes or if they're at certain thresholds, because again, there's always going to be nematodes in the soil. No matter what, you will have some plant parasitic nematodes in the soil. It's about if you're surpassing thresholds, and if they're causing damage. So tolerant turf varieties. So Bahia grass is really tolerant, but of course, a lot of times we don't like Bahia grass as much as the other grasses. Um, but if you know you're in a really nematode heavy area, you can use resistant varieties. Like everything else, reduce stress, proper, plant care is going to be really important. Aerating soil, again, I mentioned this many times. It's going to improve the soil or improve the health of the turf, which will minimize the amount of nematode pressure. And there are chemical options, but they're mostly only for commercial use. And they're just really new chemistries because we're trying to come out with more stuff, but there's very limited chemical options when it comes to management. And even with the options available, again, they're in soil, they can get pretty deep in the soil. So even when you fumigate, like you're not getting rid of them entirely. All right, so here's just a, general, more philosophical question. What is something you've noticed about the management for all these diseases? Or I guess another way to word this is, have you noticed similarities between all of these diseases? Like, has there been topics that I keep bringing up over and over again? Pretty much. Um, too much water. That is very, very true. Basically, what I'm trying to get at is while pathogens differ, and we're kind of trying to figure out the differences between the different pathogens, the strategies for managing them really come down to a lot of core strategies. So if you have someone coming in with questions, a lot of times we kind of want to get down to the root cause, because maybe if you're like me and you just like science and you find it cool to differentiate the pathogens, if they want to go through more of a fungicide route, you definitely want to know more about what is the pathogen, because that will determine which fungicides you choose. But you don't always have to know exactly what disease is causing what problems to kind of be able to give a good management plan regardless. So just very generalized overview. Again, we want proper irrigation and drainage. Don't over irrigate, don't under irrigate. Try to have, we want soil that has adequate drainage. Of course, we can't always control that, but if we can't control drainage, we try to manage irrigation differently. Soil health and fertility, don't over fertilize, don't under fertilize. You can always experiment with, trying to increase the organic matter in the soil, because again, the more organic material we have, the more beneficial microbes and the more of the regular ecosystem we're cultivating, which is going to have natural checks and balances. So we want to think about soil health. Clean and sanitize lawn equipment. This is really important, especially if I'm like talking to landscapers. If you're going between houses, you want to, at the minimum, like blow off the lawnmower to remove all of the leaves or anything that is on there. And ideally, you would also have some sanitizing solution you could try and spray and have some ways to sanitize as much as you can. Increase mowing height and shade in during winter. So again, shade and winter are just inherent stressors. So we want to minimize stress. And so sometimes this means we kind of move the mowing height, which not a lot of people do. A lot of times they have a set mowing height, they go out and they mow that height all year round, or they do that on the entire lawn, even though this lawn is in full sun and this lawn is under a giant oak tree. So you can work around with the different mowing heights. And then improve aeration. So this is really, really crucial. We want to have air getting to the roots. We want to be able to kind of see the soil. So if you look at some lawns and you look at them and you kind of just try and like put your hand and move around the soil, you just cannot see any soil no matter how hard you try and dig. you're just seeing grass and then thatch. So we want to kind of have some access of the soil to, we want it to be covered by the canopy of the leaves. Um, and I can comment on aeration. I will do that at the end. We want to have some cover of, we don't want it to be, the soil to be exposed, but we want to have some, airflow moving in and out. Um, and so again, urban soils are often very compacted. What I will say about aeration methods besides the rake, there are different ways to aerate. One of the most common forms to aerate that is usually done in, and it's the most severe, not severe in the sense that it's bad, but severe as in it's, the most intensive way to decrease compaction is to do plug aeration. And it's basically just this machine that will take out little tiny plugs from the soil. Um, and you can leave them on top of the soil. It just adds some air and it allows the roots to move. And this is done really frequently on golf courses and athletic fields, and again, managed turf. I have been really struggling to find good resources for urban landscapes. Not only that, but I have also recommended aeration to a couple people, and they've mentioned that they have a hard time finding landscape companies that also provide aeration services. So that's been a really big confusion factor for me because every EDIS publication you look at, everywhere you look, aeration is #1 recommended to minimize these diseases. But it's also very hard to find resources for urban landscaping. So there are ways to aerate. You have spike aerations where you just do spikes. There are certain things called liquid aeration. It's basically, it's mostly just microbe. It's like, you know, chemicals that kind of increase the microbe populations because the more organic material, the more microbes, the more that they will naturally aerate the soil by decomposing and exchanging gases. So aeration is complicated, and there's not enough research on urban soils and aeration. So that's something that I feel like we definitely need more of. Um, and again, we want to have deep, infrequent irrigation events. And then when chemical control, this is definitely something that we can and probably should do if we want to have really perfectly manicured lawns, but we need to do it preventatively because they don't actually kill the fungus. They just prevent the spread and the infection. If we are going to use more chemicals, we want to rotate modes of action. So we don't want to get resistance. Resistance is pretty common in turfgrass systems. Um, and sometimes resistance is local, so it's like one house can have a resistant population. The next house over doesn't. Other times you have resistant populations that spread, and then all of a sudden, this one product does not work on anything. And then, of course, we always have to follow the label. The label is the law. That is, rule number 101 for extension is the label is the law. And if you are uncertain about how to apply fungicides, this is usually the point when you would want to get like a landscaping company or do more training on applying fungicides. All right, so here is just, I guess, me getting on my soapbox. So I have like two more slides or something like that. One thing I just want to mention is sometimes we're not aware, but when we think about turf and lands and lawns in general, we are really putting them in the worst possible conditions possible. We are putting them in soils that have had most of their organic material and nutrients stripped. They have high pH because they were, some of the soils were moved, filler sand was moved in. They have concrete and other contaminants that are affecting the soil. They are severely compacted from all the activity that's going on. So what ends up happening is we have this grass that we're trying to get to grow in these really bad conditions. So they have very limited root growth because compacted soils, their roots are supposed to go down deep. If we think about, grasslands, they have some really deep root systems. And then if you go look at the root system of a traditional lawn, it is just, 2 inches deep max. So we're really hindering their ability to grow. And a lot of times this means we have to really baby them if we want them to grow properly. So because they have shallow root systems, we need to irrigate more frequently. We need to fertilize more often. They don't have the ability to take in the nutrients that are further down in the soil zone because the roots are so hindered. Um, and so what this means is basically we can make turf look good, but it requires constant inputs and it's pretty labor intensive. Um, and resource intensive, and it's not something you can usually end. So you can get your lawn looking perfect, but that doesn't mean you can't, you're not gonna have problems the next season or a year down the line. Um, so basically, we just kind of have to reframe our expectations, and this is something that is hard to communicate with people that are expected, that they see perfect lawns and they think that they can do that easily. So what we have to understand is how to communicate the issues regarding turf. So that's kind of what I'm getting at, is I'm sure most of you know that, we don't like turf around here. Um, or actually, I'll move to the next slide. So let's go into a little bit of psychology for a second. And this slide is for me more so than anyone else. I am a fundamental turf hater. I would much prefer we focus on, ground covers and or just let the lawns be. Green is green, I don't care. Um, but sometimes we have to understand that, we are from a unique perspective, and a lot of people really like having uniform lawn space. They don't want to change. They want it to look uniform. They like what it, you know, kind of like that suburban dad thing. They just like having the good lawn. It makes them look better towards their friends or whatever. Or maybe they want a really good space for their kids to play around in. If you just let any weeds grow, some of them can, have thorns or something like that. Um, so there are reasons why people really want to have nice grass. And this is, the status quo bias. So some people just don't want to be that weirdo that's, has wildflowers instead of, grass. And so what we really need to focus on is trying our best to not necessarily change people's minds. If they're gonna have grass and they want to have nice grass, then that's for them. We can, we just want to nudge them towards better practices and more realistic expectations rather than fully 180 switching up their ideas. Um, so that's kind of the point of this slide, is to be is could I kind of think, just reflect upon how we interact with, if we're on a tabling event or in the clinic and someone comes in, you know, some people really like the grass and you just got to accept that. And we're just going to try and nudge them towards better practices. All right. So here is another slide, which I'll probably put on a Word document or something like this and send to Kathy. So these are some questions that kind of get you thinking. So if you have someone come into the Master Gardener Clinic, and they have a problem with their turf, or it can work for other stuff too, you kind of want to ask these questions so you can start, getting in that detective mode. I have a little detective person here. So examples can be, when did you notice the issues? So we want to remember diseases take time. Abiotic conditions tend to develop a lot faster. What is the distribution? So diseases will start in one area and they will slowly spread. Abiotic factors are more uniform and they're more widespread. So if they just tell you this is, front yard, backyard, both are experiencing the same issue, that rings the little bells in my head. That's maybe it's something else. Um, or if they're yeah, my turf and also the, jasmine I have in my lawn or my bed, my landscape bed are both affected, then I'm that's weird. Diseases don't tend to jump different species like that. How often do you water? When do you water? This is really important because sometimes they have literally no idea. So the irrigation goes off in the middle of the night and I don't know anything else. So that can be important too. Has anything changed recently? Sometimes they'll say something that means nothing to them, but the second they say it to me, I'm oh, that actually makes me think of something. And then again, mowing height, schedule, sometimes they don't know any of this, but it gets them thinking that, oh, maybe I should think about how high I'm mowing or if I have a schedule or routine. Any products they've applied, have they seen anything specific? Is the problem getting worse, better, or staying the same? So those are some questions. And again, I recommend having them at hand so you can kind of get yourself thinking about these things. And then here are resources. Again, we just have a million EDIS publications, most, and they're pretty, substantial. They're really good EDIS publications. But of course, we don't really have everything. Like I said, I'm really looking for us to have a good aeration guide for the home landscape, but we don't have that yet. These are two books that I have in my office. If anyone ever wanted to borrow them, that would work. For the water quality and quantity book, they have a more recent version that's a PDF download. This is a link to the Plant Diagnostic Center. So again, I used to work here for like 3.5 years. So if you ever want to send in a sample, come by me and I'll let you know how to send in the best sample. And at the Plant Diagnostic Center, they have different faculty like Dr. Phil Harmon. He is really good. I worked with him for a while. He's really, really knowledgeable with turf diseases. So if we ever get ourselves in a pickle, we can always reach out to him. But of course, there's a bunch of other faculty. So here are the EDIS publications that I would recommend. Again, I'm going to give my presentation for Kathy to distribute. So she can give you all of this so you can have this at hand. And then that is the end. I have a survey, and if you were on my presentation last time, I had a survey as well. This one is similar but a little different. One of the things I added on here was so like the difficulty level. So I really want to tailor this to like where you guys are at. I don't want to be speaking about things that are too challenging or too easy. So if you want me to change the content in any way, like I said, this is, I'm still new to this. I'm tailoring how I want to present this information. So that would really help me out. The other thing I want to say is I am trying to work on like either a flow chart or like a dichotomous key, which is basically so like a decision aid tool that can kind of help you guys go through the process. So if like someone comes in, it will start something like, what is the distribution? Is it widespread? Look at abiotic issues. Is it, small, or is it more limited distribution, maybe disease or insect? And then kind of go through a flow chart or a key to help you get more of an idea about whether this is what kind of issue we're having. So in a way to help you guys with making kind of these decisions. But of course, if I make this, I want it to be for you guys. So I want to know how you guys would think it would be formatted best. So like a flow chart versus, the dichotomous key where you go, it's like either yes or no, yes, it's this, no, go to this question. If that makes any sense to anyone. But yeah, fill out the survey if you want to help me out with the content. But other than that, I'm done. And if you have questions, again, the chat or just talk. So yes, top dressing does help. And there was a study that kind of really showed how adding an organic material really does help with the turf establishment. And this was done on lawns that were being established. But when you top dress, it's adding organic material. It's obviously ideal if you would like till it into the soil. But if you have the turf already there, top dressing is the next best thing. So yeah, a lot of times you will aerate and then top dress, and that will kind of really increase the growth. But an important thing to note is if you do want to aerate, you want to do this when it's growing rapidly because it is actually kind of damaging. It's, it's causing, it's really disrupting the turf. So we don't want to do in the winter when the turf is dormant and it's not going to grow out of it. So we want to find times when it's actively growing. It'll grow and heal from the damage and, hopefully be better on the other end of it. But yes, top dressing with compost is usually really effective as well. And when you do top dress, it is possible that you're adding in, potentially some of the negative stuff too. But you're also adding in the beneficials that kind of, again, have those checks and balances. So when it comes to like disease and insect pressures, in general, we're going to see less of them in the home landscape than in managed turf. Because when we have like, turf sod farms, they know how to manage the turf so it has the best conditions. The problem with home landscapes is we don't understand the conditions that turf likes to grow in. So it's almost always the conditions that aren't great. And it's the disease that's kind of secondary to that. Um, but in general, because especially have less managed turf that has weeds or it has, different types of grasses competing, that kind of also helps manage everything because certain, say Augustine is really susceptible to take all root rot. Bermuda grass is a little bit less susceptible. So if you have like a mix of them, you're going to have less disease incidence in that rate. And you also have more biodiversity, which again adds those checks and balances. So in general, I would actually say diseases are less common in the home landscape. A lot of people they see an issue with their lawn and they immediately want to think it's a disease because they think that if it's a disease, they apply a fungicide and that's a quick solution. So what we really want to do is rephrase people's ideas so that they realize that it's not a quick solution. Again, fungicides are only so effective with dealing with fungi in the soil. Um, so it's trying to communicate that we need to work on the conditions more so than everything else. And again, it's hard to say that because there's less research on top dressing with compost than there is on fungicide trials. So it's a hard balance, but in general, we want to focus on the conditions. Alrighty. I
Hey,
think I'm
then
done.
I have just a couple of
Yeah.
comments rather than questions.
Mhm.
I really like the idea of a key to diseases. There is a small one in the Florida Lawn Handbook, Your Florida
Yeah.
Lawn, and I found that to be very useful. So anything
Mhm.
along those lines would be great. And
Yeah.
is that a newer edition of Your Florida Lawn? The picture you showed looked different from what we
It's
have.
it's the one I have in my office, so maybe it's the older edition. I don't know.
Maybe.
Um, it is definitely possible. They have a new edition of the BMP, I noticed when I was looking at that, but the BMP is more for sod producers, so you really have to sift through it in order to get the stuff you're looking for. The best course of action is really just the EDIS pubs. They're tend to be most up to date.
One thing I've noticed about homeowners is they know how often they irrigate, but they have no idea how much
How
water is
much?
actually going down
Yes, that is
onto the
really
lawn.
important.
Yeah.
Also, they don't really understand what's going on with the roots at all. And part of that is because it's just underground and they don't want to take up some turf to look at the roots. So that's a big thing. We're like, well, how deep are the roots going? They're like, I don't know. And I'm like, well, you're probably irrigating a lot for roots that are only in the top like 3 inches of the soil. So yeah, maybe we'll have in the future more classes on how to do the catch can method to kind of see how much you're actually irrigating. Um,
Yeah,
very,
we actually have a few tune-up kits in the plant
yeah, I've
clinic
seen
to
them.
give out. Yeah.
Or they don't know how big their space is, so they apply fungicides incorrectly because they're just guesstimating again the area. And when you look at the label, it's like this much per 1,000 square feet. Like, oh, this is about 1,000 square feet. But again, they're probably completely off. So that's another thing.
Mhm. Well, that was some great information and really good for master gardeners. I learned a lot myself too. So thank you very much. Are there any other questions?
One thing I will also say is there are apps as well that do kind of like disease diagnostic stuff. I've only fiddled with like two of them and they're pretty good. Um, some of them are just broad scale, so they'll have also like cold season grasses type diseases. So they're not really specific to the stuff we see down here. Um, but those are also an idea, but you need to kind of be more specialized in order to know what they are. Um, yeah, difficult when HOA's in charge of irrigation and lawn care. That is another beast in it of itself, is getting HOAs to understand these practices. Um, so yeah, this is easy if you have control over your irrigation system, but yeah, not everyone does. But yeah, so there are other keys as well that are useful. I just wanted to kind of create one that's more of like really specific to like what we're going to deal with here and get rid of all the fluff that is useless or might distract someone. But other than that, we're good. So thank you guys for listening. Fill out the survey if you have suggestions about how I can improve these talks, and that's it.
Okay, thank you, Caitlin, and we'll see you next month. We haven't set the date yet, but we will do that very soon. And next month, we'll focus more on landscape plants.
Yes, so next month it's going to be landscaping, like garden stuff. So stuff you'll see in your landscaping beds, like ornamentals, and then also some vegetables.
Okay, great. Well, we
All
hope to
right.
see everybody there.
All right. Thank you so much.
Thank you.
Mhm.